So I'm not sure where Caleb is gonna put the conversation I just had with Pete. I guess maybe right here works. So plugs, wires, coils, injection cleaner, another shop did because he was complaining about it running poorly.
It died, I think, on him.
And then it was towed into that shop then?
I guess, yeah.
They did all that and it ran okay?
I guess it ran when they left, yes.
And then it broke down on him again?
Yep.
And it's here?
It's here.
It's a no start?
No start.
Okay. And so we have a Hyundai that's a no start. We're honestly suspecting fuel pump, but hopefully it's still a no start. I haven't even tried yet. I just put the scan tool on it. We haven't identified the vehicle and I haven't tried to crank it. So fingers crossed this doesn't start. It was a really long crank time. I didn't want it to start. That's really upsetting. That means let's both get in the car. We'll look at some data, take it for a ride, see what happens. All right, so it's 2008 Hyundai Accent with a 1.6. Somebody's hands have been in here, so we could have codes that aren't part of our problem. Crankshaft position sensor circuit malfunction. So when I was cranking it, I did not see, and I know you guys didn't see it either. We weren't focused on it. I was watching the tachometer. When it wasn't starting, I was like, okay, sweet. And then what I noticed is initial cranking, that tach wasn't moving. And then I watched the tach rise, and I was about ready to say, oh, we have tach movement, and then the car started. That kind of matches a crank position sensor fault. Our suspicions of fuel pump are maybe changing now. Let's see what our freeze frame shows. I don't know that this will really be all that helpful. Freeze frame data usually isn't all that helpful, to be honest. No freeze frame data. Okay, thank you. I want to go back here. We're going to cheat a little bit on this. If you have the ability to cheat, then you should, and that is using the troubleshooter. In the past, the troubleshooter was always a really, really good guide. All right, P0339 is our code, because this is specific to the car. And it says this description of the code, PCM sets 339. If PCM does not receive a signal from the crank position sensor but detects cam position sensor signal, that's when it sets the code. Possible causes: poor connection, damaged harness, open or short end signal circuit, faulty crank position sensor, faulty PCM. And then it gives me a little bit of diagnostic aids here. It says the crank position sensor detects a rotation of the crank by using a Hall effect type sensor on the target wheel that's mounted on the crankshaft. Okay, good info. There are 58 slots on the target wheel. One tooth is larger, which causes a sensor to generate voltage when the larger tooth passes per revolution. PCM uses crank sensor to determine speed, engine speed, timing, ignition timing, injection timing. Nothing as far as like, hey, this is a common fault, but it's still good information as a guide approaching something that's unfamiliar. Right away, intermittent fault. These are tough, man. These are tough because if we can't duplicate it, then we can't make a proper call. That's just not what we're doing here on camera, right? We want to prove it. I just now am nervous to drive it. We should be more prepared on the test drive, because if it dies and I have no RPM signal on the scan tool, I'm gonna want to check this crank sensor signal. And so I think before we go for a ride, Caleb, we do exactly that. Let's get test leads connected to the crank sensor so we're much more prepared for a failure. One of the other reasons that I grabbed this Snap-on is the Vantage program. So the guided component test, which is a remnant of the Snap-on Vantage, which was a lab scope with a database. I want to look up info on this crank sensor, where it is, where's it located, where's the connector, best testing point. And this is all stuff that no other tool out there has been able to duplicate what Snap-on has with the guided component test meter, what they call it. We'll go to engine, go to crank sensor, component information. Awesome. So that's different from what the troubleshooter said, because it said it was a Hall effect, and this is a 2-wire crank signal A and B. It's not a Hall effect. So there's some discrepancy there, Snap-on, within your troubleshooter and your component test meter. This is a magnetic type sensor that generates voltage. So that's pretty standard when you see a 2-wire crank sensor. 2-wire crank sensor, you're looking at an AC sine wave. A 3-wire, you're looking at a digital square wave. Hall effect compared to a variable reluctance sensor. And so according to this is a VRS, and there's many names for a VRS: permanent magnet pulse generator, a pickup coil, a magnetic pickup, a variable reluctance sensor, all of those names. Why did I choose a variable reluctance sensor? It just was easier to abbreviate than any of the other ones, because I can write VRS. That was really why I stuck with that name. And honestly, it was John Thornton that taught me that name, like in 2002 at Jim Linder's Guru classes. So if you want to know where I got the name variable reluctance sensor, it would be from John Thornton, who's like the best trainer in the world. So if he calls it that, I feel like I could call it that. Anyway, this is a VR type sensor. Best test location: connector on the crank sensor harness. Says crank sensor mounted on left side of engine near the flywheel. You guys see, like, as a mobile diagnostic technician especially, how awesome it is to have that kind of information at your fingertips. Let's see if we can locate that. It says left side of engine block near the flywheel. So the crappy part about filming outside is Caleb has to constantly adjust for the sun and for the shadow, and this is going to be one of those shots. It's going to be a little bit tough, but I'm going to use my Phil's long probe as my pointer. Transmission bell housing right here. Dude, I'm about to burn my arm. Look with my readers. Like, legit. Let's see if it gets hot. Let's see if I can melt the hair.
Dude, that's wild.
Anyway, focus. Bell housing. Says left side of the engine near the flywheel. So where's the flywheel? Flywheel's in the transmission. Transmission's right here. Then I see a 2-pin connector right here. I'm assuming 2-pin. But I see a connector right here. This is the oxygen sensor connector, but the bottom one underneath goes down right into the engine block right there. That should be my crank sensor right there. All right, so this is a variable reluctance sensor, means that it makes its own voltage. Sensor that makes its own voltage, 2-pin. Yeah, that's it. Got a white and a tan. Does it give me those colors? Yep, white and brown. There's your white and brown. Connections for these vary. I'm not going to get into all the specifics of this, but sometimes you do want to go between the two leads. At other times, when you just want a signal, going from the sensor positive wire to battery ground is all you need to do. You do not need to go between the leads. In the case of a no start with a weak signal, we may want to go between them to make sure we're getting full amplitude of that signal. And Caleb can share a picture, an image right here from my book. This is in chapter 22 when I cover ignition system inputs with my class. And one of the things about this type of sensor is if the signal's weak during cranking, it may not be seen by the computer. And this image shows that. This shows the weak signal. This shows the digital conversion of that signal. Remember, computers don't operate off of analog signals. They operate off digital, zeros and ones. So we take that AC signal this crank sensor creates, and we convert it into a digital square wave. And what you're looking at in this image is a weak signal that at times is not being recognized. Even though we can see the signal, you see underneath there's no square wave conversion. But when the signal crosses this threshold that I've created on the lab scope, which by the way I use plus minus 500 millivolts peak to peak, you can see that signal's being seen and it's converted. So in a scenario like this, it might be important that we do both leads to the sensor itself for full amplitude. And that's going to vary depending on design, because some designs will have a signal on the crank low and the crank high, while other designs only have a signal on crank high and nothing on crank low. Just variations in how they build these VR type sensors. Let me read some tech notes here. It says, While cranking the engine, the tach will read 0 RPM if there is a problem in the crank sensor or ignition circuit. Try shaking the sensor connector to see if it affects engine operation. Any change in operation noticed, inspect connectors, looseness, poor male, female terminal fit. And typically when you do wiggle and tap tests, it's the sensor that's the problem. We can start with that. I'm totally fine with the flat rate version of diagnostics here. And that's exactly what I would do. If I'm in the field, I'm gonna start it, tap on it, crank it. Very fast startup that time. Sorry, Phil, I'm using your electrical probe for something I shouldn't be. Just tapping on the sensor itself. Wiggle the connection. Nothing. All right, let's do a measurement, see what we got, and I'll tell you whether or not we need to go between them. All right, so we're gonna do a little theory and operation. I said we were not gonna talk about that, but I lied. It's important in this application because of symptoms and the code we have and trying to recreate the fault, making sure that we are viewing the proper amplitude of this component. So I'm going lab scope volts DC. A DC setting on a lab scope will draw both AC and DC content, so we don't need to pick AC coupling for this. I'm going to battery negative first with my black lead, and then I'm just going to go to the top crank wire. Let's see what we got. There we go. We absolutely have a crank signal, and this looks horrible. So this is some lab scope stuff. You know, guys that aren't familiar with lab scopes, you definitely want to get some lab scope training. This is called aliasing right here. What's going on is there's not enough samples to see the signal properly on this 2-second screen. So you do one of two things. You jack your sample rate up or you drop your time base down. In our case, I'm dropping my time base. You want more lab scope training? We have that too. It's available on my website, ScannerDanner.com. Now look at the difference at a lower time base, how much more clean that signal is. And the reason why it is that much cleaner is because there's a lot more samples taking place on this screen than on a 2-second one. And so I'm really right now focused on amplitude. If you look at the graph to the left, you see 0 over here and you see 4 over here. So it's about a 0 to 4 volt on a high-low signal, roughly. We can put cursors in there. I don't need to do that right now. My next step, I'm gonna go to the other crank sensor wire, the white one. All right, so I do have a signal on both crank positive and crank negative, and you see it's about the same amplitude, 0 to 4. What that means is if I go between the two leads, the signal is gonna double, because as one's going high, the other's going low. So if we go 4 volts high, we're going 4 volts low, what's the difference peak to peak? 8 volts. So if I put my meter between the two, which I'm now gonna do, we should see double of what we see here. Chapter 21, ignition inputs, I have this. It was an example of a Ford that uses a floating ground, and why at times, if you look at this graph, you can see how low the amplitude is connected to battery ground, but look how high the amplitude is when I'm connected to sensor ground, and that's what I'm about to do. So I'm gonna switch my lead. So I'm taking scope negative, and I'm now gonna go to the sensor itself. I don't want these leads touching each other. It'll stall the engine out. It won't hurt anything, but watch the amplitude of the signal now when I do this. Look how much higher it is. Now I haven't changed my scales at all, so I gotta move that so you guys can see it, but that's drastically different. Let me move my 0 point up so you can see. And there you go. It's exactly what I described. This is now an 8 volt peak to peak. So this is one for an intermittent no start condition, for a stalling condition. I absolutely want to be looking at sensor ground, not battery ground, because on this design, there is a signal on sensor ground. Other designs out there, sensor ground on this VR type sensor is equal to battery negative. So on those designs, it doesn't matter if you use sensor ground or battery negative, your amplitude's gonna be the same. I know this is a lot. I have classes on this. You guys should be part of them. Sit through it. This is where all of that theory comes in on an intermittent problem, and you're trying to reduce the variables in what your causes are, and understanding circuit operation and designs is everything in this situation. But we're ready to test drive it. I'll run my leads. I wish I had my test drive leads. I don't. Let's make sure these pins are in good enough for our test drive. This would be an example where I may actually want to pierce over back probing because the test drive, and you have vibrations in the pins with your test drive, that can change things. It's another variable. We try to eliminate variables. I'm pretty comfortable with this though. I think we'll be okay. All right, a characteristic of this signal is you're gonna notice when I drive it, the amplitude is gonna rise. That means the min-max voltage, amplitude. And then also the frequency is gonna change as well. So as we accelerate and the RPMs are higher, you're gonna see a signal that grows. See how much it grows? So what I'm gonna do for us to make this more clear is let's drop our time base down just a little bit. We're gonna fill our buffer faster with this time base, but let's also change this voltage scale to a 50 volt. So we're still plus and minus 8 volts, but now I'm on a 50 volt scale to kind of show you guys what this signal looks like. So now we're just kind of watching the crank sensor, looking for a drop in the signal, and I'm gonna go higher RPM just sitting here. Watch the signal. That's 20 volt peak to peak. The spike of that is positive 20 and minus 20. That's a 40 volt peak to peak. It's funny, I get people all the time that say, you're gonna hurt that sensor with that test light. Am I? Am I? Am I gonna hurt this sensor? Am I gonna hurt the computer? So I can just show you, you can do bypass testing on these and create the signal with a test light. And I get that question a lot, is like, oh, aren't you gonna hurt the computer on that? Nope. Not with a 40 volt peak to peak. I'm not gonna hurt that computer with my 12 volt test light. It really sucks that this car runs good. Let's do a test here. Hopefully I'll keep my eyes behind me for cars. What I wanna do, because we were talking about the fuel pump earlier, I'm gonna do a wide open throttle O2 test. Some of you guys know what this test is. This is a narrow band O2, and we're gonna watch it wide open. Should be rich the whole time. Still at wide open, still at wide open. Full rich, full rich, full rich. This engine is not starving for fuel. If this was a fuel pump that was weak and was deteriorating and pressure was dropping, we would see that, use this test as a guide, as a first step to put us in that direction. That's not the only thing that can cause lean conditions under heavy throttle. Mass airflow is another one, but very, very good test to say whatever drivability problem you have, if you see full rich on your O2 sensors and the car's not getting out of its own way, the bottom line, it is not a fuel delivery problem. You need to go in another direction, and in that case, restricted exhaust is where I would go next, seeing something like that. I only did that test here because, honestly, the way Pete was talking, the way the customer was talking, we were thinking fuel pump the whole time. We went to my brother's shop and picked up my fuel pressure gauge to do this case study because we really thought it was going to be fuel. See how old this is? Might be able to get a part number on that. You know, I'm always complaining about the Snap-on leads too, right? Look at the distance. Positive, negative. So I like that feature too. Bam. Lots of room now. All right, so we're just kind of waiting on a crank sensor signal to die on us. Very unfortunate, the position that we're in. At this point, I think it's best you just show, they don't need to see my face. So you sit back, turn yourself sideways, and let's take everyone on a ride to the legend of the Green Man.
Again.
That's the best test drive we have.
It is a good.
So you guys ever hear of the legend of the Green Man? So
Legend says that he was struck by lightning, turned green, and his face was all disfigured, and he would appear in this tunnel. There's a lot of different versions of the story that I've heard over the years.
This crank sensor signal looks fine. This is honestly one, guys, if I'm working in the field, I'm communicating with the customer right now. Here's the fault code we got. I mean, my opinion may change on this test drive, so let's be clear about that. But if you have 10 more cars waiting for you to troubleshoot today, to work on today, to get figured out today, you're not going to have a lot of time to spend test driving a car like this. So then you present this information to the customer. Let's start with replacing the crank sensor and go from there. Sometimes that's an okay approach. We got a code for the crank sensor. The symptoms match. I mean, it would help to hear the symptoms a little better from the customer, but symptoms, I think, match a faulty crank sensor. And it's one where it makes its own voltage, so it's not relying on a supply from the computer. It's just sensor, makes its own voltage, sends it to the computer. It's not going to be a computer fault typically for this. Could be a wiring fault, sensor fault. Yeah, depending on the trigger wheel or the drive plate or reluctor or whatever you want to call it, tone wheel. You can have issues in there too, but this being part of the crankshaft itself, highly unlikely. And it's an intermittent fault, so usually you have a reluctor wheel problem. It's not intermittent, it's all the time. Got some cool case studies though. I'll plug my premium channel again. You guys are interested in this one, just type in, you premium members, type in 29 volts in the premium search on my website, 29 volts. I had this Ford Explorer, crazy case study with 29 volt feed going into the engine computer, and long story on that one, but the part I wanted to talk about is when we were done and we fixed that problem, we had a no start or a misfire, and it was because of the reluctor wheel was wrong on the replacement pulley. It was too long of a pulley shaft, so it stuck out further than it should, and it misaligned the teeth on the reluctor to the crank sensor, and then during the sync notch, it wasn't properly gapping that sync. That's the missing tooth we read about earlier, the 58 minus 2 teeth. We're missing 2 teeth. That's your sync notch. Anyway, the sync notch on this Ford was incorrect because it was a replacement pulley and it wasn't the right distance. And that was one, that car ended up getting an entire engine harness and engine computer, all kind of other stuff. The whole interior of the car was ripped apart, all because of a reluctor wheel problem that was built into the truck at some point when they changed the pulley. So we pull over, show the Greenman Tunnel, because it's not this one. The one that the
one back there, yeah.
The one that's up on the hill up here.
Okay.
Yeah, this is one. Honestly, I would have no problem putting a crank sensor in this.
You think?
Yeah, and this is where the fix it button helps you. So let's go to the trouble code.
Just to see how common that is.
How common it is. What's given me confidence to say this needs a crank sensor? Honestly, nothing. The only thing I have here that I can go by is that I do have a crank sensor code. Mm-hmm. The 339 code is here. Mm-hmm. And then the symptoms are here. The long crank time that I saw with no tachometer movement, and then all of a sudden tachometer movement, and then the car started, that in itself was telling me we're missing crank sensor signal. Combine that, and I didn't know that initially, but combine that with the code, and I'm about as confident as I can be that this crank sensor is faulty. Now, what's unusual about this one, and I think I've seen this before on a Hyundai, I think it was a Hyundai, I have it here on YouTube, it was a friend's, that it was a crank sensor fault. The car would continue to run, but we'd drop tack, the tack would drop, and then it would run funny. That was one that has a very elaborate cam signal, and it can run without the crank signal. I don't believe that this model can. In any case, what's unusual about both of these scenarios, that car that I filmed before and this one, is this thing sat for a couple days and still was not starting. Typically when you have crank sensor failures, it's a hot failure. They fail when they get hot. And when I asked Pete about this, he called me, see today's Wednesday, he called me on Monday about it. Wasn't starting on Monday, didn't start for him on Tuesday, and it had a hard time starting for us on Wednesday. And that's just unusual, but I have seen this before on the Hyundais, that it's not temperature related. Me sitting here running it and getting it hot and trying to make it do it is like, it might be helpful to just turn it off for a minute, which is what we're gonna do. Then we can look at the stream and
give them a nice tour.
Let's give them a tour of the Greenman. So this is in South Park. This is the story of the Greenman, the legend of the Greenman. There's an actual write-up on this. This was on like Discovery Channel, History Channel. And there's an article of this guy who is the Greenman. I believe that he was electrocuted. Mm-hmm. It wasn't lightning, it was at a job.
Yeah, he was working on power.
Yes, he was electrocuted and he was very disfigured. Mm-hmm. And he used to walk down here at night because he was so disfigured, he didn't want people seeing him. Mm-hmm. And this used to be Snowden. So this is in South Park where we are now, but this area of South Park was Snowden, but there's stories of this guy, and so that's where the legend of the Greenman was born, is people were like, oh, you know, kids in those days were like, oh, there's, you know, this monster walking through the tunnel, and, you know, that's the legend of the Greenman. So this is Greenman Tunnel that we're looking at, like where that car, he's beeping going through, he's beeping because you can't see on the other side.
That is not Greenman, right?
No, that's not Greenman Tunnel.
They call it that.
They call it that. The Greenman Tunnel is actually this old train tunnel up here. We can walk up and see it. They store salt in there now.
Oh, do they?
Yeah, there's salt stored in there for winter usage. But this tunnel, I have heard, they call it Corvette Tunnel, because apparently at one point in time, 2 Corvettes collided head to head. And given the way the tunnel is designed, like you can see that, but so I've heard this tunnel called Corvette Tunnel. I've heard this tunnel called Greenman Tunnel. Technically, yeah, you hear them beeping on the other side. That's the only way you can let people know you're coming. Single lane, because the creek goes through it.
It's a really stupid tunnel.
Let me shut this off. We'll let the car sit for a minute. Let's get out. That'll be a nice hot soak for the sensor. So yeah, they stock this stream, which is pretty cool.
With what?
Trout.
I see people fishing here.
Oh yeah, people fish here all the time. Yeah. Here, let's walk across the street up to the tunnel. Yeah. Well, let's get a shot of the tunnel first over here. Dude, he's going awfully fast around that corner.
I know.
That's a little sketchy because you never know when a car's coming the other way. It's kind of a neat design. Like, what's cool about this tunnel is about a mile down the tracks. That's annoying. All right, so a mile down the tracks, like in the middle of the woods, there's another tunnel. It's built exactly like this, and it goes nowhere. It's literally in the middle of the woods. It just, the road ends. Like it just, they used to use it at some point in time in the mining days, but we called it the party tunnel. So I'll pull this picture in. This is a picture of us at the party tunnel. And it was just like this. We would sleep in there on the roadside, right? And we would just have, you know, fires and half barrels of beer, and that's what we did, like as kids, the party tunnel. One of my friends in here is no longer with us. His name's Jimmy Hackett. Rest in peace, my friend Jim. When we'd hang out at Hackett's house, we often found ourselves at the party tunnel. So this was all mining town, right? Remember, you're in Pittsburgh, like the Steel City. So we had mines everywhere. So everywhere all of us live, or underneath or over top of old mines. This was the Greenman Tunnel. Back when this guy lived, 40s, 50s, 60s, I'm not sure when, this would have been an active track. And then at night, he would be walking through here, not the road, because he's trying to avoid people. Even today, look where all the kids hang out, right? Clearly. So now they just store salt in it. And honestly, I feel like they don't even use this. I think they just stuffed a bunch in there to plug it up. I miss the days when it was illegal for me to drink beer and we had to go hide in the woods and drink beer. It was way more fun. It was way more fun. Like, I don't even care about drinking anymore. Like, it was a lot more fun when we weren't allowed to do it. Caleb wants me to leave some graffiti.
I doubt there's anything in it. No, right? Just like Dan.
Dan was here, except my name's not Dan.
Put Dan.
I can't.
That looks horrible.
I can't. Why did you take that garbage with you? How could you deface that? Man-made stone that way.
What are you doing now?
I don't know. We're gonna drive this car back to Pete's, tell him to put a crank sensor in it and be done with this car. I mean, unless we can catch it doing it, we'll make an attempt. Let's go. Nice little 10-minute hot soak. See what we get. No signal. No signal. Let's go, let's go. We're stuck here now, so maybe I shouldn't be as excited, but look. No signal. Let's make sure we're live. Make sure this is moving. You gotta be careful with your scope sometimes. That is live. There we go, now I got a signal. I had no signal there for a second. That was perfect.
Sweet.
I'm at the sensor itself, okay? The only thing that could cause no signal measured at the sensor itself in this scenario is a wire that is touching ground, okay? Somewhere on the housing, because remember that the sensor, let me see if I can do this, illustrate like this is my engine computer. This is my sensor. Sensor generates the voltage, sends it up, over, down to the engine computer. So what makes the voltage? Sensor makes the voltage. Where am I measured? I'm measured right at the sensor itself. It requires no external voltage from the computer like a Hall effect would for the sensor to work. This sensor makes its own voltage. 2 wires go back to the computer. I'm measured at the sensor. No signal in this location. We just proved it. The only possible cause, forget the computer, not a cause. The only possible cause is bad sensor, no rotation of the crankshaft, and that's not the case because clearly the car cranks over and this is an intermittent fault, or this harness in between is touching ground. If the harness is touching ground, what tells me it's not going to be a wiring issue is this was temperature related. We sat here, it hot soaked, it failed in the way that I thought it should fail, which is the hottest that this engine is going to get is on the first 10 minutes of shutdown because the coolant stops flowing, cooling fan stops, no air movement, hot soak. The engine bay gets really hot. That's when this failure occurred. This is not going to be a wiring problem. That is enough right there to tell me that code was real. We can have false codes. We don't want to replace parts based on codes alone. The P0339 code can be false. We just went through a case study on a 339 on a Jeep that it needed a factory crank sensor. That was a nightmare. By the way, what do you think I'm going to tell Pete as far as what type of sensor to get? Factory sensor only for this crank sensor. It's not wiring. I don't think it's wiring. We'll do a quick visual, but not for the way this is acting. It's not going to be wiring. Wiring also would be I hit pumps and it shuts down. Faulty sensors can act that way too. So, you just got to be careful. But the code, I remember. I was talking about changing parts based on the code alone. Like we can't do that. We can't do that. You can sometimes have false codes. I've seen on cars in the past a faulty cam sensor set a crank sensor code. I've seen faulty crank sensors set cam sensor codes. It's not unprecedented, so we can't put all of our weight on a code alone. But seeing the failure and having the scope connected was absolutely key in being confident in making this call. Pretty cool failure we were able to catch there, son. Be nice to catch one on the road here. I don't want to break down, but it would be nice to catch a dropout while we're driving it too. My only fear of that will be that it'll be really hot and we'll be stuck for a while. Let's see if we can get it hot there. Whoa, what was that? I never lost a signal, but I hit a rev limiter. It's not going over 4,000 RPM right now. Okay, this might be a default strategy with So this is the ignition cycle that set the code. I think
You restart it.
I think if I shut the key off and restart it, this problem's not going to be here. So we have something new going on. And I think the best thing for you, Caleb, watch the tack. I'm going to floor it. It's going to hit 4. And it hit a rev limiter. I'm not losing my crank signal, all right? All right, just to prove a point, we got no one behind us. Shut the car off. I might regret this. Restart. Okay. Let's see if that problem's gone. If it is, that is from the code setting. Let's see what we got.
Yeah.
So what that is, that's a strategy that this car has, and that would make sense, man. That would alter the customer's symptoms. They're going to say like, oh yeah, low power misfiring. That would be what that felt like to the non-trained ear. That was a rev limiter to the trained ear, and that was happening because the ignition cycle that when I cranked this engine over, I was cranking. There was no crank signal. So what's the computer looking at? Computer's looking at the cam. It knows I'm cranking the engine over, sets crank sensor code. All of a sudden the crank sensor comes back to life and it starts. But what's in memory right now is a current hard fault for a crank sensor failure. And that, what we just experienced, is a default strategy with that code setting, a current ignition cycle code setting for the 339. It's putting a rev limiter at 4,000 RPM. That's pretty cool. That's pretty cool. I didn't expect that, because now it's perfect. And then all I did was a key cycle. What a fun one to do. You know, there'll be people that say, well, why didn't you show us the new crank sensor when it was installed? I am showing it to you right now. You want to know what the crank sensor signal looks like? Here, have a look. It looks like this. By the way, we just had a 50 volt peak to peak on this.
That's wild.
50 volts. This sensor made 50 volts. Good stuff in here, man. Lots of theory involved in making calls. For you guys that say, I would have put a sensor in that just by reading the code, I don't blame you. That's not what we're doing on this channel. We're trying to prove faults. I'm not going to change parts based on codes. I have about 1,300 videos that tells you why you don't want to do that. There's always those ones. Proving it is key. What would you charge for this? This would be just a regular flat fee, whatever you agreed upon with the customer that you charge for diagnostic time, your initial diagnosis. I don't think there'd be any additional fees. There wouldn't be any additional fees. Some of the diagnostics we've done, there would be, not on this one. So diagnosis, which involves testing and proving. What's the diagnosis? The diagnosis is not just putting a scan tool or reading a code. It's proving the fault like we did. And then, of course, you get the repair as well. So last thing we will do is just a quick visual inspection. I'm going to shut this off, too. We'll do a quick visual inspection of the crank sensor wiring. Just make sure we don't see any, chafing anywhere, and we'll make the call. But the symptoms of this were not wiring related. They were temperature related. Where my engine computer lives on this, I do not know. Just following my wiring, it goes over this way, comes over here, goes into this harness here, and then engine computer's right here. So one of the things you want to look for when you're looking at harnesses, you see this harness mounting point. You see a bracket just to the left over here. There's a metal bracket. And then there's a strap that goes around the harness, and the strap is still intact. If that strap was broken, you would want to look real close at that harness right there and make sure, move it, make sure it isn't rubbing through. We've seen those before. So that would be the only area in the harness that I can see, and it's intact, and I have no problem with what I'm seeing. Yeah, so another area, so where the harness is right here, it looks like it's pushing against this, which is a rubber hose. Now, when I put my eye on it over here, it's not it's not touching it. So you see there's an air gap between the harness and this. But even on rubber, we've seen harnesses rub into plastic and tear through. That 2018 Lin Bus Failure or 2019 Chevy truck was plastic. It doesn't have to be metal. It can be plastic. It can be anything. But there's an air gap there, so we're good. We're good. This harness looks fine. I have no problem with what I'm seeing at all. Crank sensor's the call. I wonder if it'll do it for us one more time right now. Let's see. Now that I have the hood open though, I'm kind of cooling it down, but let's see what we get. Fired right up. Let's do one more thing for you guys. What I want to get for you guys is a cranking min-max voltage on this sensor. And so I'm going to drop this back down. We'll go 10 volt scale. And then I'm going to shut the car off, hold my pedal to the floor, gas pedal to the floor. We're going to do a clear flood type crank. No clear flood mode on this. All right, so then what we're going to do, let me drop this down to a 5 volt. And then we'll take this down to 10 milliseconds. I'm going to crank it. Pause it. Zoom. We'll get the lower portion. You see the lower portion of this signal is where we're cranking it. So in here, this will be our cranking speeds. And what you can see as far as min-max voltage goes is about plus and minus 1 volt. Okay, so that's a pretty standard cranking speed right there. And you can see down here in the valley, look at my scales to the left. I can pull a cursor in, but it's not necessary. It's about -1. Okay, you know what? I'll pull a cursor in. And cursor 1 is 0.989, cursor 2 is -0.921. Our delta is 1.9, right? Our difference in potential is a 2 volt peak to peak. That's pretty damn good for a variable reluctance sensor. I think that's why they did use the signal on the negative, was to increase that amplitude, because these signals need to be high enough to be converted. But I just wanted to get you guys a crank capture, because that's when you'd be checking it, right? You'd be cranking the engine over. This is maybe a better one here too, because it's a little bit less because of compression pressures. As far as our amplitude, let's get one more measurement. This one's a little bit less than what we saw. Our delta now is 1.6. So 1.6 volts peak to peak. That's valuable. Some of you understand how valuable it is to have that kind of information. This is just a capture of this thing starting up. What's it do? A weak signal, and it grows and grows and grows with RPM. That's what you're looking at on that screen. We're done. I'm gonna tell Pete to put a crank sensor in this. Last piece will be, let's rescan. Yeah, there's our crank code, and I will clear this for Pete. Anytime I clear codes, I always like to reread them, make sure it cleared. It did. We are done, guys. I hope you enjoyed that one. We appreciate you guys being here and helping support what we do. We couldn't do this without you. So thank you, and we'll see you next time.